Question number 1 of 8.1, it says, if the diagonal of a parallelogram are equal, then show that it is a rectangle. In the question, it has been said that the diagonals are equal. So we did a parallelogram with diagonal AC and BD are intersecting each other, both are equal. We need to show that this parallelogram is a rectangle. To make it a rectangle, we must make all these opposite sides equal. The opposite sides must be equal and the angles must be 90 degree. So we took a two triangle here, A, B and C, and we have taken D, C and B. In this two triangle AC and BD, which is a diagonal, it is equal. It is already given in the question. AB and DC are the opposite sides of the parallelogram. Those are equal. Here the BC is the base, common base of the two triangles. So it is equal. It is common. Therefore, we get this two triangle is congruent with side congruent rule. If these two triangles are congruent, we can say that the angles B and C, that is angle ABC and angle DCB, is equal by CPCT. Now, if we look at this diagram, AB and DC are the parallel lines where BC is a transversal. So it is actually like this. A BC is transversal here. Now if the BC is transversal, these two angles that we said to be equal makes 180 degree. Those are internal corresponding angle. We wrote here. So from 1 and 2 we can write angle ABC equal to angle DCB. These are 90 degree as both of these angles are equal by CPCT. That makes the parallelogram a rectangle. In question number 4, it has been said that ABCD is a rectangle in which diagonal AC bisect angle A as well as angle C. We need to show that ABCD is a square and diagonal BD bisect angle B as well as angle D. 8.1, question number 4, it has been said that ABCD is a rectangle and diagonal AC bisects angle A and angle C. We need to prove that ABCD is a square. Now you can see they have already said the diagonal AC bisects angle A and angle C. That means if we number these angles as 1, 2, 3, 4, we can say that angle 1 is equal to angle 4 and angle 2 is equal to angle 3, as bisects means the diagonal cut the angle equally. Here we wrote. So we have written that since every rectangle is a parallelogram, so ABCD is of course a parallelogram. We can now use the old formula where we can say AB is parallel to CD and AC is a transversal. So angle 2 and angle 4 is equal. Those are alternative angles. Similarly, angle 3 and angle 1 are also alternative if AD is parallel to BC and AC is a transversal. From here, we can see in triangle ABC, angle 3 and angle 4 is equal. That's why AB is equal to BC. If angle 3 and angle 4 is equal, then AB is equal to BC, as we know that sides of the equal angles of a triangle are equal. Similarly, we can say that angle 1 and angle 2 are equal and DC is equal to AD. The sides of the equal angles are equal. That makes this parallelogram a square as all the sides become equal now. Now, in the second part of the question, they said the diagonal BD must bisect the angle B and angle D equally. As it is a square, so the diagonal must bisect the angles equally. We can write, that's why we have written, since ABCD is a square and the diagonal of the square bisect the opposite angles, so the BD bisect angle B as well as angle D.